In problem number 4, Matt has red and purple jelly beans in a bag, and we're told that 2/7 of the jelly beans are purple. Okay? Matt's sister loves red jelly beans, and she steals 84 of his red jelly beans from his bag. And after that, he only has, we're told that 1/3 of the remaining jelly beans are red. Okay? Part of this problem is just keeping track of red and purple and what they're. Make sure you read carefully and know what they're talking about. Okay, so we're starting out with 2/7 of the jelly beans are purple, and after his sister steals some jelly beans, we have 1/3 of the jelly beans are red. And the question asks how many purple jelly beans are in Matt's bag. All right. Well, in order to solve this, it's probably best to use algebra. Okay, so let's define some variables. Let's say that P is equal to the number of purple jelly beans. All right, and we'll call R the number of red jelly beans. And then we can use P and R as if they were numbers that we knew. Okay, so we can write expressions using these numbers. So let's look at the first statement. We're told that 2/7 of the jelly beans are purple in the beginning. So I should also qualify this and say that these are the numbers of purple jelly beans and red jelly beans at the beginning, before his sister steals anything. Okay, so these are the initial values. Let's see, how can I write that? So these are the initial values. Okay, so these are the numbers that he starts out with. Okay, so we're told that 2/7 of the jelly beans are purple. So that means that if we knew the number of purple jelly beans, we're calling it P, but we'll pretend like we'll use it like a number. So if we knew that number, we would put P over the total jelly beans, which is P plus R, right? That would be equal to 2/7 once we reduce that fraction, right? So we're given that. So that's one thing. Essentially we're just taking this statement and rewriting it as an equation. Okay, so we got that first part done. And okay, so Matt's sister steals 84 jelly beans, and then he's got 1/3 of the jelly beans are red. Okay, so let's write that out as an expression. So 1/3 is equal to the red jelly beans, but that's the red jelly beans after she steals 84, so it's R minus 84. Okay, so after she steals 84 jelly beans, the number of jelly beans we have left is R minus 84 over the total number of jelly beans. Okay, and after she steals 84, we still have P purple jelly beans, but now the number of red jelly beans is R minus 84. Okay, so now we've taken this second statement, 1/3 of the jelly beans are red, the remaining jelly beans, and converted it into an equation. Okay, so let's work with these equations and see if we can solve the problem. Now, if we have two unknowns. We have P with the number of purple jelly beans and R, the number of red jelly beans. Okay, and if you have two equations and two unknowns, you can usually solve the problem. Okay, so we have two equations and we have two unknowns. Let's take a look at this first half, or this first equation first. Okay, so what I'm going to do, I'm going to cross multiply, okay? Now, you can also think of it, you don't have to think of this as cross multiplication. Essentially, you can think of this as multiplying both sides by p plus r and p plus r, and also multiplying by 7, okay? By 7. And that will, 7 over 7 is just 1, so that gets the 7 off the bottom, out of the numerator, or sorry, the denominator on the left-hand side. And p plus r over p plus r is also 1. So what we're left with is 2 times p plus r is equal to 7p, okay, because we got this 7 here and we have the p, so that's all we have left on the right-hand side. And then we can simplify this further. If we multiply through by 2, that gives us 2p plus 2r is equal to 7p. So we have p here and we have p here. So let's subtract 2p from both sides. Then we get all of the numbers involving p on one side. So 2p minus 2p is 0, so we're left with 2r is equal to 5p. And that would mean that r is equal to, oops, I think what I'm doing here. So r is equal to 5/2 p, okay? So now we have r in terms of p. Alright, now let's take a look at this other equation here. We have 1/3 is equal to r minus 84 over p plus r minus 84. Again, we can cross multiply, or you could think of multiplying both sides by 3 and both sides by p plus r minus 84. Okay, so let me just show you that result. So if we take 1 times p plus r minus 84, we get p plus r minus 84 is equal to 3 times r minus 84. Okay? So now I get got rid of the denominators here. So let's multiply through here by 3. I'm going to say 3r is equal to, whoops, not equal to, 3r minus 3 times 84. Okay? I'm not going to multiply that out because I know I have an 84 over here and I'm lazy. I don't want to multiply 84 by 3 because I think I can, since I see another 84 over here, I'm just going to leave it as 3 times 84. Okay? So, okay, so we still have p plus r minus 84 over here. Oops, 84. So let's get p by itself because we've got p over here and we have only r over here. So it's pretty easy to get p by itself. So we can say p, if I subtract r and I add 84 to both sides, so minus r plus 84. Then I get, okay, 3r minus r is 2r. And over here, I've got 3 84s and I add 1 84, or sorry, actually, I've got negative 3 times 84, and I'm adding 1 84. So now I actually have only 2 84s. So taking a number by times 2 is pretty easy. So to save myself a little bit of work, so this is just 168, right? So I can say that p is equal to 2r minus 168. Okay? So now we have two equations here that are simplified. Let me scroll down and give us some more room. So what I'm going to do, since I have an expression for r in terms of p, I'm going to take this which is the same thing as r, and wherever I see r over here, I'm going to replace it with this 5/2 p. And that way I can get an expression in terms of just p. Okay, so this is called substitution. So for r, I'm substituting 5/2 p. Okay, so then we get p is equal to 5/2 p. Now actually we have 2r here, and here's 2r. We could substitute for 2r. But you can see that 2r is just going to be 5p. Okay? And this is 168. Alright. So I think what I'm going to do is I'm going to subtract p from both sides, and I'm going to add 168, just so I can get positive numbers. And then I get 168 is equal to 4p. And then you will get, if you divide 168 by 4, that's just dividing by 2 twice. Okay, so if I divide by 2 once, I'd get 84, and if I divide by 2 again, I would get 42 is equal to p. Okay, so what I'm doing is I'm dividing both sides by 4. Okay, divided by 4, and then 4 over 4 is just 1, and then 168 over 4 is half of 84, which is 42. Okay. So that's what they asked for, right? They asked for the number of purple jelly beans. So we can write that. Therefore, the number of purple jelly beans is 42. Okay? And we can actually use that and go ahead and find out how many red jelly beans there were initially. And that, it's always, a lot of times with simultaneous equations, it's good to check when you're all done. And so I could say that r is equal to 5/2 p, so it's essentially going to be 5 times half of 42, which is 21. So r is equal to 105. So you could take those two numbers now and plug them in and make sure that 2/7 originally the original number of purple jelly beans was 2/7 of the total. So 42 over, this would be 147, right? If I add the two, 147, that's 105 plus 42. That should reduce down to 2/7. Okay, and that's a good way to check your answer, to make sure you didn't do. It's easy to make a mistake, so this gives you a check. All right, so there you go. The answer is 42, which is the answer to life, the universe, and everything.